Welcome, everyone. Welcome. Thank you so much for joining me. Thank you for being here with us for the inaugural Knowledge Fellowship Seminar Series. My name is Mr. Aegis, and I will be your host. And I'm so glad to have you all here with me on this Friday afternoon. Before we begin, before we even get into the introductions, I want to thank all of the many TKF educational streamers, all of their supporters, their viewers, and especially all of those who have put so much work into this committee and the organization and the management of this group over the course of the 7 or so years of this group's life. I want to take this opportunity to introduce all of you to the Knowledge Fellowship, if you're not familiar with us already. Throughout this time, TKF has worked in a supportive role to promote educational content and streamers, and this event, which we will dive into shortly, will be a more active and present role in directly spotlighting a very important segment of the streaming landscape. The Knowledge Fellowship is a community of educational live streamers and viewers with an interest in sharing and obtaining free, credible, evidence-based information through live streams. TKF is a fellowship, a collection of educational content creators, people who use the vehicle of live streaming to deliver meaningful, legitimate, educational content from people with educational or experiential subject matter expertise, not just opinions and influence. So TKF educators use their expertise to provide free information on a wide range of subjects. Their backgrounds are diverse, with credentials or experience that give them valuable knowledge. In the pursuit of equitable learning, viewers from all backgrounds and educational levels are invited to engage with our TKF streamers. TKF includes over 100 affiliated educational streamers across dozens of different subjects or specialities. So if you are interested in interactive content that makes you think, teaches you something new, allows you to participate in meaningful conversations about the most interesting stuff in the world, there is a TKF streamer or 2 or 10 that's talking about something you might want to see right now. So before we go further, I want to open it up to you for questions, comments, anything that you have on your mind. If you are new, if you have questions about us, please let me know. And thank you so much for all those who are currently following the channel who are new. And of course, you can also follow our stream team so that you can always have someone available that you can watch to learn something from. Whether that is in the field of aerospace, which there are multiple streamers in the group for, geoscience, physics, life sciences, mathematics, yes, check out the TKF stream team, absolutely. We'll have a link in the chat very shortly. Physics and astronomy, practical education, practical skills, practical technology, programming, practical crafts. I'm hoping to maybe learn to do a little siding because I had baseball-sized hail crash through my roof last week. So maybe I can find someone who knows a little bit about that can teach me something. And yes, actual education, that is you. Absolutely, let me turn the volumes up. Very important to your streamer, whoever you're watching, to always let them know about the audio levels. Social sciences, yes, I've been watching a TKF stream team member, Zach App, learning a lot about social science. Hello, Don Does Math, Slayer Darth. Yes, in fact, Slayer Darth, we do have a TKF channel. Has not been used in some time, but we're going to start using it now for these monthly seminars. During these seminars, a host like myself will be spotlighting a TKF stream team member. They will be giving a presentation on something in their subject area, something of interest to them, something that they have going on in their field lately. Maybe if they are an astronomer, an asteroid's passing near Earth, so they might talk about that. But once a month, we're going to feature a new TKF stream team member so that they can tell you all about themselves. And you can meet new educational streamers, and we can use the vehicle of the TKF channel to spread the word of all of our wonderful streamers. We also hope that this channel will begin to be used more for additional types of events. I would love to have roundtable type discussions as well, where several members who are all within one particular group, say a bunch of programming streamers get together and they talk about something going on in the programming world. Conclave style, that's not the right word. I'm thinking of the Pope thing. You know, that would be fun to watch, I agree. What do I teach? I am a health teacher. I am a health and wellness teacher. I teach Phi Ed. I give health and wellness lessons on the weekends. And I'm doing well. Thank you so much, Dragon. TKF getting together to elect a new pope. Yes. The College of Owls, I guess, since we are now owls. And hello, NapFan. Thank you all so much for your work as well. Yeah, so if you have ideas, if you have thoughts about what we can do, things that we can do to further our mission, the mission of TKF to spread and promote and highlight educational content creators, by all means, let us know. You can reach out to me. You can reach out to the Discord. Link to the Discord, if you are not in the Discord already, will be in the chat. Even if you are not a content creator, even if you are not a teacher, even if you don't stream at all, you can always join the Discord, because we're always happy to have new people to talk with and chat with. If you're just a learner, if you just want to talk about educational stuff, just want to ask people questions, by all means, join the Discord. It can be difficult to keep track of all of those many different Discord servers that we're all in. So hopefully we'll get people to put that TKF Discord towards the top. And I completely agree, Slayer Darth. We don't want to gatekeep knowledge at all. We want that to be as open source as possible. That's the goal. So if we bring together all of these wonderful streamers who are already choosing to use their time to spend their expertise, their education, teaching people things for free via the vehicle of live streaming, all the better. It's a one-stop shop. Like I said, if you have an interest in any educational topic, there's someone streaming in TKF who talks about that very thing. And you know what? Poison Mouse, Tiny Toxic is a good streamer. In fact, Tiny Toxic Tofu is such a good streamer that they are going to be one of our next guests on this seminar series. So stay tuned. Make sure that you're following the channel, because they will be featured coming up. Well, welcome. You're new on Twitch. I'm glad to have you with us. And like I said, if you are educational, if you are just a regular streamer, if you are interested in educational topics at all, learning in STEM, you can hang out in the Discord. You can find new people to follow. TKF, I have found to be a wonderful resource. You joined up on Discord as well. Bravo. Very good. Very good. Happy to have you. If you know of other educational streamers, you should nominate them. You can, in fact, nominate people to become a member of the TKF stream team, of the educational streamers that we have. We have a Google form that you can fill out to let us know, hey, there's this great educational streamer I know of. You should reach out to them and add them to your group. We'll have a link to the Google form for you there in the chat as well. And I think you're right, Slayer Darth. I think COVID really brought it up even further to the forefront. And then, of course, people get busy. Life has somewhat returned to normal. But I think the population itself, the viewers out there, are yearning for educational content. There's so much, let's say, slop out there. There's so much inconsequential, insubstantive content out there. People want something that they can learn from. And as great as YouTube videos are, as great as recorded content is, I think people have an interest in not being talked at, but being talked to. And that's something that's unique to the interactive form of live streaming. where you can actually talk to the person who is teaching you. You can ask them questions directly. If you're not clear on something, you can get that immediate feedback. So I think that the vehicle of live streaming and the goal of TKF is only going to get more and more important as education in some ways becomes more walled off and more expensive, but through the magic of the internet can be accessed if you want. And I agree. Yeah, YouTube can be hit or miss. Sometimes there's no substitute for hitting the books. And if you have someone who you can reach out to talk to directly, to interact with directly, who can guide you in the right direction, I think that's even better. We're in a world of ChatGPT, let's be honest. But that isn't real feedback. That isn't a real person who can understand what you mean and respond to you in a meaningful fashion. Absolutely. And you know, Slayer Darth, Florine is always willing to give me book recommendations. Well, I think that we should bring on our first guest. But first, let's show a few clips so that you can get to know them. Our first guest is going to be Moohoodles, who is a science communicator who has been streaming live on Twitch for a long time now. Very experienced, has done a lot of great content. So why don't we introduce them by showing you a few clips of this amazing streamer.
One. Oh my gosh.
Wow.
That's so cool. Oh my god.
Go find life.
Oh my gosh, the sounds here. Wow. This is so cool. It's the same boosters they used on Psyche. It's the last time they're using those. What? This is unreal. Look at this as well. I cannot believe we just streamed that.
I love that clip in particular, showing people out in the field, showing people doing things in person, getting hands-on. I think that's something that is really great for viewers to see, showing that you can get out there and do things. It's not just passive learning. You can go out there and be active.
Like Hubble Space Telescope is one of the reasons I got into space in the first place, or I guess even more into space, was looking at these images. And I think it really speaks towards how important these space telescopes and science stuff in every field, but obviously we talk about space in here, but like how important all of this stuff is, because if Hubble Space Telescope didn't happen, and Hubble is older than me, y'all. Hubble is older than me. If that didn't launch, I might not be here doing science communication, and countless other people in the world would not be astrophysicists, planetary scientists, whatever fields they went into, cosmologists, like they just wouldn't, astronomers, like so many people would not be doing this stuff if they had not seen these images or they weren't inspired by the Hubble Space Telescope. It has such an immeasurable impact on humanity, not just in America, not just in Europe.
Completely agree about Hubble, just the cultural gravitas that it holds. You mentioned Hubble and everyone knows what you're talking about.
If you like this image, please go here. Don't just zoom here though. Go over here, click this download option, because this is like the huge image file, and zoom in on that and enjoy having your mind be blown, literally blown. This image came out April 24th, 2007. So I was in Nagrand in Burning Crusade, looking at the pink like filaments in the sky with the floating islands. Yes, in World of Warcraft, okay? And then looking at this between battleground cues, like, okay. It was awesome. It was amazing. It was amazing. Like, so yeah, download this image, Carina Nebula, Hubble image, zoom in and just have your mind be blown. Like, it's so cool. And look, Mystic Mountains over here. One of my favorites. It's one of my favorites. I love it.
And it's pretty.
This is my favorite slide. Because it's just so aesthetic. So we have the pillars of creation here seen on the left from the Hubble Space Telescope. In the center, we have the James Webb Space Telescope's NIRCam image. And on the right, we have the JWST NIRCam and MIRI composite with Chandra X-ray data over the top of it. So I just wanted to point out that Hubble is still doing stuff. There's other space telescopes, and we can learn so much from each like visible light spectrum. Those are all like different spectrums of light, and we can learn a whole bunch of different things about it. So space is cool. And look how pretty it is.
I know, right? I love it.
One.
So, with those slides, with those clips, I think that gives you a pretty good idea of the kind of streamer we're going to be bringing on. So, without further ado, let's bring on our guest, Moohoodles. Let's give a warm welcome. Hello, Moohoodles, welcome.
Hello. Hi.
Hi, hello.
Thank you
How
so
are
much
you?
for having me on here. I really appreciate it. The entire intro was amazing as well, by the way. Thank you for
Thank you.
all the effort you've put into this and getting it all together and everything. Yeah.
Very
you.
happy to be helping out such a great group. So, first off, tell us, what are your areas of interest? We have a pretty good idea given what we just saw, but what topics do you like to get into your streams?
So we do science communication on current news in outer space and astrobiology. But I also talk about sharks, which are my favorite animal and have been since the 3rd grade. And I talk about conservation as well as programming, which my degree is in, and I'll get into that soon. But yeah, I know it sounds weird and disconnected, but I swear it's all very connected. I also play video games on my stream from retro up to newer stuff. And so I kind of bring the educational content into some of the games we play, especially like any space theme game. I'll like bring the education into it, which is really fun. So
Awesome. So, sounds like sharks were something you were always interested in. Were you always interested in space? Was that something you always wanted to do as well?
I feel like I always had an interest in space, but it was not as much as my shark interest until a bit later on in life, actually. The clip I was talking about with the Carina Nebula Hubble image, I feel like is when I got a bit more into space. And the love of astrobiology came a little bit later because I actually didn't know it was a field. I didn't know it had that name until I was already deep into loving it, which is kind of funny, but yeah.
Yeah, it does seem like something that's a little bit more Star Trek, like studying biology in space. But it's something that you can really study if you're out there watching and interested. What is it about live streaming that appealed to you in sort of presenting science content? What is it about live streaming that you think is unique?
Oh my gosh. Yeah, I think Twitch is the perfect platform for doing science communication stuff because it is a live environment and it's interactive. So you can be really engaging with your audience and also answer questions. I feel like that's such a barrier with people learning about science and maybe getting into it and getting more excited about it is that, you know, they have questions and they go unanswered or, you know, there's some knowledge gaps. So I think if you're able to like live answer questions, it's so beneficial. And yeah, I think Twitch is the perfect place. It's been so great. Yeah, I started streaming 11 years ago.
Wow.
Tomorrow, May 3rd,
Well, happy
2014.
anniversary.
Yeah, thank you. Yeah, there wasn't educational content on Twitch back then. Like there was not non-gaming categories. So Twitch has changed a lot over time, but I would still kind of nerd out just while I was playing video games back then because it was, you know, my special interests and the things I was interested in. So my conversations just naturally went into, you know, talking about space things. So yeah, it's been an awesome journey.
Yeah, I mean, I think a realm where video games are common is going to be a place that attracts nerds. So I think there's definitely there's been rich soil. Yeah, I would say I've certainly experienced this. There's some challenges though. There are challenges to trying to deliver educational content via Twitch, live streaming in general. What would you say are some of the things that you've had to deal with, had to overcome in terms of trying to get your content out there?
Oh, that's a good question. I feel like it kind of changes over the years. I feel like some of it is just kind of like discoverability and stuff. I think Twitch has gotten a whole lot better with discoverability recently, and people know like education on Twitch is a thing now, which is great. I think there's been, you know, a lot of trolls or like science deniers and things like that. And that's always kind of hard to handle. That's something I personally struggle with sometimes, because it's like I want to take the time and have the kindness to, you know, help someone change their opinion or actually like learn things, right? But sometimes people are just trying to troll and you know, that's kind of it, and you can't really help them. So I think it's kind of like keeping the peace in chat and also helping educate people and, you know, having like empathy and kindness. Having empathy and kindness isn't hard, but I think trying to keep the peace in chat and like help people learn stuff, you kind of learn to read like people in chat, I guess, over time as you stream. But yeah.
I think the interactive aspect, of course, also does lead to an easier way to build community. Is that something you've certainly felt as well? Do you feel like you know, that community is something that's been with you for a while? Are the people there within your chats that you've known for years?
Oh yeah, absolutely. There are still people from like my 2015 streams, like January 2015, still come into my stream. And that is so surreal to me. Like, I've known these people for a really long time and they're awesome. And I've forged a lot of awesome friendships on Twitch too. Yeah, I think community is the most important thing, and I am always so grateful for it. I get cheesy every stream. I didn't always have friends or people in real life who were interested in space, and I've always had a lot of online friends, and being able to have made a little corner of the internet where people are interested in space and want to chat with me about it and want to learn more. And some of them are like professors in astronomy and they know more than I do on a lot of things, and it's like the most amazing environment to just foster like passion and knowledge, and it's absolutely incredible. I'm so grateful for this platform and anyone who's a part of my community who has been in and out of my streams before.
That is awesome, and I completely agree. And speaking of all of your love of space, why don't we let you give us your little presentation on what you do, and I will turn it over to you for your presentation. All right?
Sure, thanks.
All right, go ahead.
So yeah, this is the first Knowledge Fellowship seminar. I'm Moohoodles. We're gonna talk about astrobiology. I'm not used to fully like giving presentation things, but I'm very excited to be here and be doing this and nerding out about astrobiology. It's not gonna be like a huge comprehensive like astrobiology overview, but yeah, I'm gonna dive into the things that I really, really love and that I would like to share. And hopefully it maybe inspires you to look into it more or come into my stream and learn more. So yeah, I'm Moo. I know we kind of covered this already, but I've been streaming since 2014. It's 11 years. I cannot believe it's been that long. I am live every Monday, Wednesday, and Friday at 7 p.m. Mountain Time. And yeah, just to be clear, my degree is a Bachelor of Science in Computer Science. Please don't think I'm like an astrobiologist and I'm a PhD and I've done a bunch of research. It's not the case. I'm very open about that on my stream, but I've been doing these educational streams for, you know, a long time, and I really love astrobiology. And yeah, and because of that, I do more of like a relaxed, learn together kind of stream where we, you know, learn about topics, or I'll like supplement different articles like with my knowledge and what I know to break it down and make it more digestible and understandable for people. So yeah, we cover a bunch of current news in space and astrobiology. Like I said, I also talk about sharks, conservation, and programming, and I play games from retro up to newer stuff, and definitely love to bring the educational content into the games I play as well. I know sharks, conservation, programming, and astrobiology all sound very disconnected, but I'm hoping by the end of this presentation, I'll show you that they are a bit connected. And yeah, you can find me at Moohoodles on everything. So I wanted to start off with a quote here, which is, "The nature of life on Earth and the search for life elsewhere are two sides of the same question, the search for who we are." And this is a Carl Sagan quote. I feel like Carl Sagan has very heavily inspired me, and a lot of my viewpoints, even before I like watched Cosmos and you know deep dove into all of the awesome work that Sagan has done. He's just absolutely incredible. And I'm sure a lot of you know that, we're all made of star stuff. Nearly all of the elements except hydrogen and helium were, created by stars in some way, shape, or form. And that, makes the iron in our blood and yada, yada, yada. And I just love that. So really learning about space is also connecting with who we are. And it's, learning about our place in the universe too. So with that said, what is astrobiology? I'm sure some of you in here are like, what is this? I get this question on my stream a lot. It's definitely a newer field, like from the 50s onwards, and I think it started picking up a lot more in the 70s. So yeah, it is a multidisciplinary field encompassing chemistry, biology, geology, astronomy, planetary science, atmospheric science, and so much more. Most people who are astrobiologists, I don't mean to do astrobiologists in like quotes like it's not a real thing, but most people who are astrobiologists actually have their degree not in astrobiology, but in an adjacent field, like maybe biology, but they study specific things that relate to astrobiology. So if a biologist wants to go into astrobiology, they could study like extremophile microbes somewhere, or maybe things in like lava tube caves, which could be an analog for environments on Mars. So it's really cool, and there's a lot of ways into the field, and astrobiologists, I feel like, from my experience, are always very kind and very welcoming and are so excited to collaborate with people in different fields. This is also something that I love about the Knowledge Fellowship and the educational community on Twitch, because there's so much overlap that we have that we might not really realize, and just having these open conversations with each other, I think could really spark new ideas and maybe spark, maybe new papers being published or something, just because two people in very different fields got together and was like, wait, I'm learning things. And that's always some of my favorite stuff to see here on Twitch and collab streams. But yeah, astrobiology is the study of the origin, evolution, and distribution of life in the universe. So a big part of it is like, how did life originate on Earth? What kind of environment was needed? What ingredients came together? What happened? This, to be honest, we're not going to be talking about this very much today, because my stuff that I'm really interested in is like life outside of Earth, like maybe in the watery moons of our solar system, or even outside of that to potentially habitable exoplanets. And an exoplanet is just a planet that is orbiting any other star that is not our own sun. So yeah, that's the definition of astrobiology there. Hopefully that makes sense. So I wanted to start in our solar system. I mean, obviously we'll start in our solar system, but wanted to just travel to a nearby planet here. So let's go to Mars really fast and talk about some cool astrobiology things. I feel like I'm just kind of going to be like info dumping on y'all a little bit. I'm like trying to also read chat a bit too. If I miss any questions or anything, feel free to like tag me if you want. I'm a full-time streamer, so I'm very used to like, chat and doing this, but I want to make sure I'm focused on the slides. So for Mars, we've sent some rovers there. We're doing a lot of cool stuff. And once again, this is kind of like a brief overview of things. But what's pictured right here is the Shayava Fall sample. So you can see on the left, there's like that little leopard spot thing, all of those leopard spots. And on the right, there's a circle showing some olivine. So this was a very exciting sample that was recently found, and they did collect a sample of it to hopefully have in the Mars sample return mission. But this made headline news everywhere, because these leopard spots could actually be created from ancient microbes, which would be so exciting. So this is what we would call a biosignature, some like strong evidence for life, because it could have been created by life. So it's really cool. However, we don't have the instrumentation on Mars rovers because essentially, our labs here on Earth are expensive, they're big, you have to have scientists, and there's a bunch of different labs all over the world. We can't really fit all of that. We don't have it like miniaturized enough. We don't have it autonomous enough to just go on every spacecraft and every rover. We don't really have a lab on a chip to be able to say, this is life, this is not life. So we really, really aim to do sample return missions if we want to confirm if there is life somewhere in the solar system. We can't do sample return missions outside of the solar system, but for somewhere in the solar system, we're aiming to do that. And yeah, the olivine, by the way, is important as well because it could be used to essentially, it would be used as like an energy source for early life forms, help with like producing sugar and stuff like that, which is just so cool. But as exciting as this could be, it could maybe have also been created abiotically, which means not from life. So abiotically means, not from life. So yeah, it could have been made from like uninhabitably high temperatures. For example, like, you know, volcanoes shooting off stuff and making olivine and everything. So yeah, very cool. But yeah, olivine is just like a mineral, a rock, a mineral. Is it a mineral? So yeah, very, very cool. I feel like that's about all I wanted to say there. But I did want to highlight the Mars Sample Return Mission, which is a proposed mission that they're trying to do, NASA is trying to do. And I'm really excited for it because Perseverance rover, which took this picture, has been going around on Mars for a few years now, and it's been collecting samples of a bunch of really intriguing spots along the way. So we can learn a lot about Mars and its past environment, which used to, you know, Mars used to have water on the surface. It used to have an atmosphere. It used to be a much more like place more conducive to harboring life. Not anymore, but back in the day it was. And an exciting thing is that, you know, if life arises, it is really hard to get rid of. Looking at past extinctions on Earth, you know, nothing ever was fully wiped out life-wise. So I think it's really exciting to think maybe there could still be life on Mars, maybe deep within the surface in some water reservoirs. Or one place I'm really excited to learn more and check out is the lava tube caves on Mars. So just little caves underneath the surface of Mars. And, you know, if life was once on the surface, maybe it's, you know, migrated down to the caves. That's one place astrobiologists are excited to look into, but it's kind of hard to get, you know, different different rovers or other things into those caves. It's a hard environment, but the Mars Sample Return Mission will be amazing as long as it is funded. And one other thing that I wanted to mention about Mars is, I know there's been talks of people going to Mars. One really strong stance that I take is that, in my opinion, before we send people to Mars, we should make sure that there is not any life on Mars, just because we don't want to accidentally or intentionally contaminate the planet. Something really important is that, you know, in our solar system, we only have X amount of objects to go check out. So if we contaminate Mars, we can never really like decontaminate it and know for sure that it wasn't our own microbes that have contaminated the environment and that's the life. Like, we're not going to know if it's life that was actually on Mars in the first place or if we contaminated it. So I think it's really important to be aware of that. And yeah, I think it was Carl Sagan that said if there's microbes on Mars, Mars belongs to the microbes. And I very heavily agree with that. I know not everyone does, but food for thought, because I think it's important to make sure that there's not life in these places before we go there, before we try to terraform them. And I'll be circling back to this later, talking about how it's more important to take care of our own planet instead of having, like, you know, a planet B, because Earth is where we're from and it's our home and it has everything we need. So I'm really excited to see what happens of the sample in the future. Now I want to take you to some of my favorites, which are the watery moons in our solar system. So Jupiter's moon Europa is one of the best places in the solar system to look for life. It is, like I said, a moon of Jupiter. It has about a 10-mile thick icy crust with a subsurface ocean that's like 40 to 100 miles deep. I think they think there's over like twice the amount of Earth's water in Europa, which is so cool to think about. Like twice the amount of our oceans is just hanging out in Europa. So in comparison as well, by the way, the deepest part of the ocean on Earth is the Mariana Trench, like Challenger Deep area, and that is 10 kilometers deep. So the ocean on Europa is 6 times as deep. Can you imagine? I think that's just so fascinating, and I just wonder if there is life in there, what does it look like? Like what kind of critters are in there, you know? I think that's really exciting, but obviously that's speculative. But they can find some kind of constraints for what life could be like, kind of noting how much radiation might penetrate through the ice, what the pressure is under the ice, and different things like that. I think I read somewhere a while ago that they think it could be small fish and not something like super huge, but I don't think the pressure is too, too much, like a lot stronger, I guess. I don't think they think the pressure is much worse than what it is in our own oceans, which is really cool. So yeah, you might see these like reddish brown lines on the surface of Europa. You might be kind of curious about those. Those are essentially like mineral salts that maybe came up from the ocean and have kind of been on the surface. It might have oxidized from the radiation, kind of splitting hydrogen and oxygen. And that actually makes a really cool environment for the oxygen and the hydrogen, like the free molecules there, to then mix in with other things and create some important building blocks for life, like hydrogen peroxide, carbon dioxide, and a whole bunch more. I'm not a chemist. You will see that as we go through this. So I'm not as good with that stuff. That is like it's the weakest part of my astrobiology. But it's really, really fascinating to learn about, and that's something I'm hoping to learn more about personally, so I can help educate people on it. But yeah, essentially, that stuff from the surface could also mix back into the ocean, create some good energy needed to sustain life. They also think that there may be hydrothermal vents on the surface, on like the mantle of the planet, which, you know, could bring a bunch of good ingredients and everything for life too. That's maybe where life originated on Earth. So it's an exciting thought. We have the Europa Clipper mission, which is pictured there, is going to be arriving, and you saw the rocket launch earlier. I got to go to Kennedy Space Center last year and stream Europa Clipper launch on a Falcon Heavy rocket. So it is going to get there in 2030 and we'll be going around Europa and learning more. It's not a life detection mission, but it will be seeing how thick the ice is, learning more about the subsurface ocean, and seeing if Europa truly is a place capable of harboring life. So I'm very, very excited to see the updates about this mission. Up next, we have my personal favorite, and this is my bias, okay? I'll be upfront about it. I think Enceladus is the best place in our solar system to look for life. And I have things to back it up. So Enceladus is a moon of Saturn. Similar to Europa, it has an icy crust with a subsurface ocean. And I love this moon. I see everyone in chat with the Enceladus emotes. Thank you. And yeah, it is a much smaller moon than Europa. Europa is about the size of our moon. Enceladus is like the diameter of Texas. Enceladus is small, but oh, does it pack a punch. So we've actually found like the 6, oh my goodness, ingredients we need for life. Sorry, my brain is like, I have ADHD as well, and sometimes my brain just blah, blah, blah. But anyways, we found the chnops, as we like to call it: carbon, hydrogen, nitrogen, oxygen, and phosphorus on Enceladus. Those are the building blocks of life. And we have found them on Enceladus. And that does not mean that there's life on Enceladus, but it bolsters, you know, the argument of this is a really good place to look for life. Unfortunately, there's no like fully funded, super planned out missions. I think the European Space Agency wants to send a spacecraft there in the 2050s. I'm impatient. I want it now, but you know, things take time. But the amount of phosphorus that they found on Enceladus is at least 100 times higher than the amount in our oceans on Earth, which is really cool. So that's really, really awesome. Essentially, phosphorus teams up with sugars, forms like a skeleton to DNA molecules, and helps repair and maintain cell membranes. It's important for life. They have a lot of it on Enceladus. And phosphorus is the rarest of the 6 elements that we need for life, which once again are carbon, hydrogen, nitrogen, oxygen, phosphorus, and sulfur. And so, yeah, it's really exciting. I super love Enceladus. Another thing that I wanted to talk about, which is on the next slide here, is Enceladus is gushing out its water from the south polar region in this area called Tiger Stripes, which are, I think you maybe saw in the previous photo. Sorry, I meant to note those, but it is gushing out water 6,000 miles out from Enceladus, which is so cool, at a rate of 79 gallons per second. I think that could fill like an Olympic swimming pool in a few hours. It's a lot of water. So the water vapor coming out actually makes a torus around Saturn, like in Saturn's E-ring. There's a torus, which is a donut shape, yum, of water vapor. I think about 30% of this water vapor stays in the torus, in that E-ring, and the other 70% just goes out there to the rest of the Saturnian system. I think that's really fascinating, and I'm so curious to learn more about it. And I'm curious to see exactly what's in that water vapor. I would love to see a sample return mission, once again, maybe flying through the plumes, grabbing a sample and sending it back to Earth so we can analyze it in our labs. Another exciting thing about sample returns is that we can also use those samples, like we can set some aside for later on, and future generations and, you know, technological advancements then can look at it with you know, the newest state-of-the-art machinery in like 30 years or whenever. But yeah, that's not planned so far, but I'm a big advocate for it happening. Another cool thing about Saturn's E-ring is that Cassini flew through it. We pretty much know everything we know about Enceladus from Cassini mission. And to be fair, though, these images are both from JWST. So the one on the left, you can see Enceladus being like that little pixel right there, and you can see the huge plume of water coming out. That was a really awesome JWST discovery. But when Cassini flew around Enceladus, it flew through Saturn's E-ring, and at the end of the mission, it actually flew through the plume. So we know a lot about Enceladus, which is why, in my opinion, it's the best place in our solar system to look for life, because we just have the most data on it so far. Maybe with Europa Clipper, getting to Europa, we'll have a lot of data on Europa, and then I'll change my mind and be like, Europa's the best. But I just really love Enceladus. So when Cassini flew through the E-ring, it found this specific silica particle. And this particle is only formed in one place that we know of on Earth. And that is a really like high energy, high temperature, underwater environment, which is none other than hydrothermal vents. And we found a silica particle that we only know of it being created in hydrothermal vents on Earth. Maybe there's another way it's made, but we found that in that torus of water there through the, you know, plumes coming out of Enceladus. So we have pretty strong evidence for there being hydrothermal vents on Enceladus as well. And I think that is so exciting because, once again, hydrothermal vents could be where life originated on Earth. So really good place to look for life. And I always, you know, remind people to advocate for the space missions you want and all of the cool space funding, you know, so cool missions can happen, even the Mars sample return. But you might wonder, all right, so the watery moons in our solar system are cool. By the way, it's not just these two. There's a ton other, there's a whole bunch of other ones, including, you know, like Ganymede and Callisto and everything around Jupiter. But outside of the wonderful watery moons, let's travel to some exoplanets out there. And once again, exoplanets are just planets orbiting any star that is not the sun. So there are, as of yesterday, there are 5,889 confirmed exoplanets. And there's 4,535 planetary systems and 7,576 exoplanet candidates, which is so exciting. So confirmed exoplanets, actually here, I'll start with the exoplanet candidates, are essentially when we think we've found an exoplanet, it's like, oh, it looks like there's a dip in the starlight, and I'll get to that in the next slide. but it looks like there's a dip in the starlight. There could be an exoplanet here. So we use a different, scientific method, yay. We use a different telescope to check it out and confirm and make sure like, oh, okay, we've seen it transit again. That's definitely an exoplanet. So we don't just see it once and say, oh yeah, there's an exoplanet. We got to see it again. We got to get repeated data. So the Kepler Space Telescope pointed to a specific area of the sky, and I'll also show you that in a moment, and found a whole bunch of exoplanets. It retired in 2018, and TESS launched in 2018, kind of taking that planet discovery torch. And now TESS, the Transiting Exoplanet Survey Satellite, is finding a whole bunch of exoplanets up there too. There's other telescopes, including ground-based ones, that also do this. So it's not just those two, but those two have definitely found the most. And most of the exoplanets we found are like gas giants or like Neptune type planets. But there's also a lot of rocky planets we found, probably more like super Earth, like much larger than Earth, but still a rocky planet, which is really exciting. So I just love this. I love exoplanets so much. But yeah, so there's kind of the difference between the exoplanet candidates and the confirmed planets. They're going through the candidates and trying to, confirm them. But yeah. So this shows like pretty much all of the exoplanets we found. That long kind of thing on the right there shows where Kepler looked. And we also have other telescopes looking towards the center of the galaxy. The sphere around the sun is where TESS is looking, because TESS is going all around mapping the entire sky. Whereas Kepler, right there, do you see that kind of grid looking thing? That's where Kepler looked in the sky. And look at all the exoplanets it found. Isn't that so cool? There's so many stars out there, and so many exoplanets around the stars. It's like everywhere we look, it's just more exoplanets. And even, maybe more Earth-like exoplanets. This is NASA's Eyes on Exoplanets, by the way. You can find a whole bunch of really cool, 3D web apps on their website on science.nasa.gov/eyes if you're curious. You can see where all of the space telescopes are in real time right now, including Europa Clipper on its way to Europa, and different things like that. It's a great educational tool, and I think it's really great for anyone, but especially kids, to get interested in this stuff. I know I would have nerded out on this as a kid. I nerd out on it as an adult because I'm just so happy I can see where all the exoplanets are. So yeah, next time you stargaze, keep this in mind. There's a lot of planets out there. So how exactly do they detect these exoplanets? And one way is, I guess first I'll say the radial velocity method, which is essentially the gravitational tug on a star and exoplanet from each other. They can kind of see like a little wobble, and they're like, oh, it seems like there's an exoplanet with this mass because it's creating this kind of wobble. But most exoplanets are found through this, so I'm going to focus more so on the transit method. And TESS is the Transiting Exoplanet Survey Satellite. So TESS uses this method to find exoplanets, and that's essentially when a planet transits in front of the sun, in front of its star, not the sun. It's not transiting in front of our star. When an exoplanet transits in front of its host star, you can see on this graph here that there is a dip in the starlight. So we can actually infer, hey, something passed in front of it, and we can learn a whole lot about it, which is really cool. So obviously we would want to get multiple transits and maybe use different telescopes to make sure that it's actually an exoplanet, and not just like a cold spotter or something on the star itself. But yeah, that's how we find a lot of exoplanets. But even more exciting is with the James Webb Space Telescope, we're able to analyze the atmospheres of these exoplanets. So you could imagine if, some alien species were out there and they were looking at our atmosphere, they would maybe find biosignatures, once again, just like signs of life. They might be like, hey, there's a lot of methane and a bit of greenhouse gases and all of this stuff. There could be life here. We're trying to do that for other exoplanets. It also helps us just learn a lot more about exoplanets and planetary formation and stuff as well. Do we need to wait long to see multiple transits? I can imagine it taking years to get multiple readings. So it definitely depends on the planet itself, because some planets So a lot of planets that we've found orbit red dwarf stars. They're the most common star in our galaxy, and also the most longest living. But red dwarf stars are colder, so planets orbit a lot closer. So they actually, sometimes will orbit like once every month, which is pretty cool. But you could imagine, Earth orbits every 365 days. So someone trying to learn more about us would have to wait 365 days, which is quite a while. So yeah, some of the exoplanets, it definitely takes longer because its orbit is further out. Some of them are really fast though. Some of them are just like a day. So we're able to get readings a lot quicker, and it's really fascinating. But yeah, definitely depends on the planet and what its orbit is. We are definitely more likely to spot the ones with shorter orbits, just because, yeah, as you know, Dawn, there's like a higher probability of it passing in front of its star. But yeah, so with JWST, it's able to do some spectroscopy. So essentially, and I'm going to do like just a little overview of this. You can see on the left, JWST does this with a whole bunch of amazing things. It grabs the light and we're able to learn more about it. But for exoplanets, when the exoplanet passes in front of its star, the starlight goes through the atmosphere of the exoplanet, and then travels all the way over to James Webb Space Telescope, and then that grabs the spectrum of it. It splits that light into its spectra, which you can see there, kind of Pink Floyd style. And on the far right over here, you can see carbon, nitrogen, oxygen, iron. So these are kind of like the fingerprints of what this looks like. So we're able to grab the light and see what elements are there, just based on like what's being blocked out in the light spectrum. This is really, really cool. And this is kind of how we know what atmospheres are made up of on exoplanets. However, it's not always that easy. It's not like, as with everything in science, right? It's not just like one and done, easy peasy. It's absolutely 100% this. There's some uncertainty, some modeling and things that go into it. And some of that varies depending on the star and what's happening on the star. So some recent stuff that has been going on is the TRAPPIST-1 system. They were kind of struggling to know exactly what was happening in the atmospheres of these exoplanets because TRAPPIST-1 is a red dwarf star. So it's a small, much colder than our sun, and very volatile star. Red dwarfs are very active. They're like with solar flares and stuff, which the solar flares might actually blow over to the exoplanets and like just completely annihilate and blow away atmospheres. But if they don't do that, it could be good places to find life. And one thing that happened when they were looking into this is that there was some hot spots and some cold spots on the surface of the star, and that actually changed the spectra reading. And maybe made something look like something else. Like maybe it seemed like there was oxygen or something, but instead it was like shifted into nitrogen. I not exactly that, but that essentially makes it harder to find this stuff. And obviously science takes time and everything anyways. But that's just, I think, an important caveat to keep in mind. It's not just like, we got the spectra, it's definitely this. And we'll get into that more in a little bit. But the TRAPPIST-1 system, as you can see here, is 7 exoplanets orbiting around a red dwarf star, 3 of which are in the habitable zone, and that is that green area that you can see right there. So E, F, and G planets are in the habitable zone. I want to talk about the habitable zone really quick because you've maybe heard it referred to as the Goldilocks zone. It's not too hot and it's not too cold for liquid water to exist on the surface. So that's the important thing about the habitable zone. It's not the only place where life can exist, right? Like, there could be life on Saturn's moon Enceladus. That's way outside of our star's habitable zone. But there's not liquid water on the surface. So when we're trying to look for life out there in the universe, it's like a needle in a haystack, right? We try to find similar environments to Earth. We only have a sample size of 1. Earth is the only place we know of that has life on it. So when we're looking for life out there, we try to find something similar to Earth. But astrobiologists know that might not be the case. There could be a planet out there. There could be moons around planets. Just crazy environments we couldn't even fathom that actually are capable of harboring life. And maybe that life doesn't even look like how we expect it to look. Maybe it's not carbon-based. Maybe it doesn't have DNA somehow. Maybe it does something else. But maybe the laws of physics make things come together in a way where it has DNA and all of that. So there's a lot of research going into the specific subfield in astrobiology of life as we don't know it. And that's incredibly fascinating to me as well. Just wanted to point that out because I know a lot of it is like, we're searching for, another Earth. And it's like, well, life could be anywhere. Why are we doing this? It refines our search a little bit, but they are looking everywhere still. But yeah. Sorry, I have a few notes on the side here to make sure I don't forget something. So you can see that this is a colder star because it's a red dwarf. So all of the planets, as I was saying earlier, orbit a lot closer to the star. You can see that this is enlarged 25% to the bottom, showing our own solar system. And all of these planets, all 7 of these exoplanets, orbit their star like way closer than Mercury orbits the sun. All 7 exoplanets. Isn't that cool? I think that's so cool. So yeah, because of that, the transits are probably a lot quicker than if you're trying to, look at another solar system that's more similar to our own that has longer orbits. So we're able to get more data quicker, which is exciting. But yeah, the hot and cold spots on the surface of the star could be, a little bit of a struggle to actually be able to see what's going on. But we're still able to learn a whole bunch of cool things. And with that, I want to talk about an exoplanet that you've maybe heard about recently. If not, that's totally fine. But K218b has been making headlines recently. Is there life on this exoplanet? Let's talk about it. So this exoplanet is 124 light years away. And once again, it is orbiting a red dwarf star. A lot of the exoplanets could be around like any star, but a lot of them that we're researching into are around red dwarfs. It's once again the most common type of star in our galaxy. So essentially with K218b, a few years ago they published a paper saying that they think it's a Hyceum world, which means a hydrogen-dominated atmosphere with liquid water on the surface, like liquid water oceans, which is really cool. They also mentioned that they found a faint signal of DMS, dimethyl sulfide, and that sparked a lot of controversy. So dimethyl sulfide on Earth is made only from life. Phytoplankton in our ocean produce dimethyl sulfide, so we could consider it a strong biosignature. However, they didn't even have like a sigma level 1 detection of it. So scientists were like, no, you need more data. Essentially for the sigma level, it's like, how much data did you get? How accurate does it seem? Like, is it enough to conclusively say, yeah, it looks like it? So just last month or the month before, they came out with another paper saying, hey, we found the dimethyl sulfide with a sigma 3 level detection, and that is like 99.997, something like that, percent certainty that it's like accurate and wasn't like a false reading. And that might sound really good, but that is not good enough for scientists. We need more. So they're trying to get some more data, obviously, and it's really, really exciting. However, there are some caveats with this that I want to point out. So caveat 1 is that a lot of different scientists, looked at the data from the initial findings years ago, and they have differing viewpoints, which is the scientific method. This happens. You want people to peer review, check out your data, see what's going on, and essentially they found some of them thought that instead of a Hyceum world, there might be a liquid magma ocean, just lava on the surface. That is very different to an ocean surface, right? And some other researchers, like exoplanetary scientists, found that it could be an oxygen-poor mini Neptune without requiring liquid water surface or life as well. So I'm curious for those scientists to get their hands on this new data and check it out and to see what their conclusion ends up being. Obviously, we'll be getting more data over time, but K218b is on a 33-day orbit, So it takes 33 days to orbit around its star. So it'll be about probably like 2 years before we get more updates on this. The other important caveat that I'd like to mention is that dimethyl sulfide could actually be made abiotically. So they think that it could be created in volcanoes. It might be out there in molecular gas clouds. And I think a paper was published this February saying that they found it on the surface of comets. So something to keep in mind. I wish it was a super strong biosignature that's like, this is only from life. This is 100% absolutely just from life. But the way it goes is that a lot of things, similar to the stuff we were talking about on Mars, can also be made not from life. So we really need to, learn more about it, get more data, and see what we can figure out. But yeah, I think another thing that would help us, I'll go to the next slide here. Like what exactly is needed to confirm the life? Another thing is, I guess I wanted to mention that, like, I think the best biosignature, because I know we're talking about dimethyl sulfide, and it would be awesome if that was definitely just made from life. I think CFCs, like chlorofluorocarbons, might be one of the best biosignatures we could find. Those used to be like in aerosols, and they've now been banned. Because we really don't know of any way that could be created besides like life making it. So weirdly enough, that's a strong biosignature, but I think it would be kind of sad to find because it'd be like ruining their atmosphere, putting a hole in their ozone, I would assume, like we did. But also another thing to look out for is a disequilibrium in the atmosphere. So dimethyl sulfide doesn't stay around in an atmosphere naturally for very long. I think it's like less than a day. So it seems like something is replenishing this amount, whether that is abiotically, maybe from volcanoes or something, or biotically from, phytoplankton. And we don't know until we look into it more. But a disequilibrium in the atmosphere is maybe something you've heard about Venus as well. Elements just kind of end up staying in like certain quantities. So when one is a bit more, it could be a biosignature. For example, on Earth, we have a bit more methane. Something is clearly producing more methane. For the most part, that's like cows farting and making methane. And you could detect that with a telescope. And so those are some, I guess, interesting things to be aware of and keep your eyes out for. But yeah. So relating to K2-18b's atmosphere, if we, want to confirm life or learn a bit more about it, essentially they need another like 16 to 24 transits of the exoplanet going in front to take that from a sigma level 3 to the scientific standard, gold standard sigma level 5. So once again, and like 16 to 24 transits is going to be like, over a year, maybe like 2 years of data, and then they'll have to, analyze it and go through it and check it out. And then peer review needs to happen, which we want to have happen. Oftentimes on my stream and just overall with this stuff, we're kind of learning about science as it's happening. I'm very clear about that because I don't want people to like kind of get too into the clickbait articles of like, whoa, life was found, and then feel like they've been bamboozled or something, because it turns out that's not the case. You maybe heard about that with like the asteroid that was, there was talks about an asteroid maybe impacting Earth earlier this year. That's not going to happen anymore because more scientists pointed telescopes at it. They got more data and they learned, hey, it doesn't quite look like it's going to hit Earth in the end anyways. And that's the scientific method. That's just science as it's happening. And I think it's so important to know those steps. And that's, part of my job as a science communicator is to talk about that stuff and help people understand that that's part of the process and that's the excitement of it. So for K2-18b, they would need and anywhere really. I know I mentioned that they want a sigma level 5 detection. They want repeatable results. So we want to peer review it. And they need to measure a meaningful and important quantity. And, as we look for evidence of life, I know I've talked about biosignatures a lot. There's also something called technosignatures, not like but like technosignatures would be a measurable sign of technology from an extraterrestrial intelligence. And those could be things like radio waves, emitting some transmissions or something that we pick up. That could be something as like awesome and advanced as a Dyson sphere around a star. So these are, things that we know could exist, and we're looking for it out there in the universe. That's something that SETI, the Search for Extraterrestrial Intelligence, does. We have other telescopes and stuff doing it. I think it's important to note that, like, yeah, there could be intelligent life out there, probably really, really far away, and we're searching for it, but we're also searching maybe for more microscopic life and stuff around. Obviously, I think if we find life in our solar system, like on Jupiter's moon Europa or Saturn's moon Enceladus, it might be like single-celled organisms, maybe some multicellular life or something. But I'm excited to see if what we find or what we don't find, because both would, really help advance the field of astrobiology and give us constraints for all of this stuff, trying to answer, are we alone in the universe? Like, that is just the biggest question. And that's something that really makes me like obsessed with astrobiology. And then I have a little note with another Carl Sagan quote, which is just the most perfect quote: extraordinary claims require extraordinary evidence. So in any article you might read or any news you come across, it's important to take note of that. So obviously we want some extraordinary evidence for this claim of dimethyl sulfide on K218b. But even then, is the evidence extraordinary enough to say it's certainly from life, or could it be made abiotically too? So some future challenges that we'll have to go through and get a consensus on. Yeah, right. I know it's a good Sagan quote. And then another thing I wanted to talk about as well is this is something I'm really passionate about. I know a lot of people come into the educational space on Twitch and they might not feel like they're smart enough to, be present or to be learning about this. I've had a few comments like that in my chat, and it's like, oh, no. Like, I do not know everything. I'm learning in here. I hope I can help you learn too. I never want anyone to feel like they're lesser than because they don't have a degree or they don't have expertise in this field, or they're just starting learning about it. It's never too late to pick up a new hobby or a new passion or to learn about something. It is never, ever, ever too late. So I want to let you all know that there's awesome citizen science projects that you can get involved in if you want to help out learning about all of this stuff. These, I guess, depending on exactly which project, are great for kids all the way up to adults, grandparents, whoever wants to get involved can truly make a difference in so many different fields. Not just space ones, there's other ones, but NASA, science.nasa.gov/citizen science has a whole bunch of things. You can find stuff on Zooniverse as well, like that Galaxy Zoo project, which is a brand new one, and you get a look at galaxies and classify what type of galaxy they are, and it's all James Webb Space Telescope images, which is really cool. So you could do it on your smartphone, laptop, whatever, and it's really, really rad. You can also see on the bottom right the Are We Alone in the Universe, trying to find signals, maybe from extraterrestrial intelligence. There's another one called Redshift Wrangler, where you look at the oldest galaxies that the James Webb Space Telescope has found and you help catalog them. So I wanted to take a moment to talk here about, just a brief moment, about, kind of computer science and the programming overlap in space stuff. And we talk about this a lot on my stream, but when I guess some of the citizen science stuff helps train algorithms, like machine learning algorithms, or AI, as you could call it, if you want to use the fancy word, not generative AI, but it trains machine learning algorithms to help computers identify things. So if we, like for Galaxy Zoo, for example, and I'm not sure if this is exactly what they're using it for, but it's a use case on other projects. If we help accurately identify, this is a spiral galaxy, this is elliptical, this is this, this is this. It has a large data set of accurately labeled images, and it can train itself off of that. And then in the future, the machine learning algorithm can then accurately classify those and go through data sets even better. Space is a massive data set. It's the biggest data set we could ever get. So there's a lot of cool things to go through. So computers, machine learning algorithms, and you could call it AI. I don't really like the buzzword, but that stuff really, really helps scientists, sort through all of this data. But citizen science is still incredibly important, even if you're just training the data sets, or maybe they're not even using machine learning and you're just doing it all for them. There's a lot of really cool ways that you can get involved. And once again, you don't have to be a professional in the fields to learn, contribute, and make a difference. Yeah. And then I wanted to close out here saying we need to take care of our planet. I'm trying to go full circle here because Earth is the only place we know of where life exists. This Earthrise photo that you can see here on the right kind of sparked a conservation, like environmental movement in the 70s because it's Earth rising up from the surface of the moon, and it's like, wow, that's everything we know, everything we love, every person. Like, I'm not gonna go all Sagan-y quote again here, but everything is on that planet, and it's just in just hurtling through space. It's our spaceship Earth. So all we have protecting us from space is our atmosphere, and we need all of the trees for oxygen, and we're inhabiting this planet with all of the other creatures on it, all of the other plants and everything. And I think it's so important to make sure that we're taking care of our planet. We do have some satellites in space helping us learn more about our planet and how we can protect it. There's a lot of great weather satellites, environmental ones. There's even satellites up there looking at, and also using machine learning algorithms and stuff, but they're looking at, for example, the Amazon rainforest and seeing if people are illegally deforesting the rainforest, and a bunch of other incredible things going on. And that kind of brings me to my love of sharks, just because I love sharks a lot. A lot of our planet is covered in the ocean, and sharks are an apex predator, an apex species. So they help keep the, food web and everything in check. So if there's if sharks, I guess if some of the sharks die off, and because a lot of them are vulnerable or facing extinction due to overfishing and also shark finning. But, sharks die off, some species will thrive and others will die. The entire ecosystem goes way out of balance, kind of similar to the wolves in Yellowstone and so many other examples that we have, countless examples over time. So I think it's really important to advocate for sharks because without them, our oceans are in danger. And, making sure we take care of our coastlines, mangroves, all of that. And even, other inland environments too. So, just because we're on this planet hurtling through space, I think it's important to remember that kind of on a daily basis. I think if more people thought about how we're all on this planet and we're in it together and this is all we have, like there is no plan B. There is no plan B. Like we need to take care of our planet. I think the world would be a much better place. So yeah. I think that's about all I had to say. I mean, I could ramble on about this forever, but I won't. But yeah, hopefully that got the point across. We definitely need to take care of our planet. It's the only place we know of where life exists. So let's honor that and make sure it continues to exist in harmony and is healthy and happy. And with that, thank you for listening to my presentation on astrobiology. You can find me at Moohoodles on everything. And once again, I'm live on Twitch every Monday, Wednesday, and Friday at 7 p.m. Mountain Time, just twitch.tv/Moohoodles. I could take some questions in chat also if y'all had any, if we have
some
time
questions.
for it.
And a round of applause. Thank you so much for that presentation. Excellent stuff. Very thought-provoking and, of course, very interesting. We all love space. I think we were all little kids at one point, all looking up at stars or watching Star Trek or our favorite sci-fi.
Yes, I love that. Thank you. Yeah, I really appreciate it. Hopefully it made sense. There's so much more that I was like, I could add all of this in there, but it's gonna take too long. So I hope that worked out good. Yeah. I have not read Project Hail Mary yet, actually. It's on my list. We might do a book club for it. But yeah, so I can't quite answer that question, but Shepard, sorry. I am curious though. I'm really curious. I've heard good things about it. What answer to the Fermi Paradox do you believe? So I should have put a slide in here about this, but I show it on my stream all the time. But I do think that life is out there somewhere. I don't think it's visited Earth necessarily. But there's countless of galaxies behind me even. Those are all too far away. We're not going to know if they have life on them. But even in our own galaxy, our galaxy is 100,000 light years in diameter. Our radio waves have only gone 200 light years in diameter, so not super far. If there is intelligent life, I just think it's too far away for us to really make contact with. or for us to get transmissions from. I kind of hate that I've arrived at that conclusion, but I just feel like everything's a bit too far. I do think there's life out there, maybe even just microbial life or, beginning stages, maybe not necessarily intelligent, but everything's really far away, and it is hard to find too. I mean, obviously we have, TESS and JWST out there finding exoplanets, looking at the atmospheres, but it's a challenge. And I think it's important to remember that this field is still pretty new. We found the first exoplanet in like 1992. So we're really scratching the surface, and we're at the beginning, exciting, like, dare I say, hype moments of, getting closer to maybe finding life outside of Earth. But yeah, I guess that's my answer. I think space is just too big. Yeah, I don't know if I missed any other questions in chat. Feel free to ask again and everything. And thank you all for being in here. Thank you for the kind words. Usually I'm a bit more chat interactive, but I wanted to make sure I was, saying all the things that we had to say. I hope it was insightful. I hope it inspired you to learn more about astrobiology. And yeah, hopefully check out more streamers in the Knowledge Fellowship as well, because there's so many brilliant, amazing people sharing their expertise for free here on Twitch and around the internet. It is awesome.
I do have a question for you. So, as someone who's been doing this for some time now, what would your key takeaway, your key advice be to someone who is maybe thinking about streaming and talking about educational content, informative stuff, making something that's more substantive? What would be your piece of advice for them?
Oh my gosh, I did a whole panel. I did a whole creator camp panel on this at TwitchCon last year. If you want to check it out, it's on my YouTube.
Yeah, let's get a link to that, someone in the chat.
Oh yeah, definitely. Denoba might be able to I can grab a link too. But yeah, it was called Designing Education on Twitch. I'm always happy to answer questions and stuff too. Yeah, if you have something you're passionate about or something like you have a lot of knowledge in, please share it. Make a Twitch stream. You don't have to show your face. Just make sure your audio is good. And I mean, I kind of hate the advice of like, just do it, but really just diving into it. I think it's important to be yourself and very much so be yourself. And like, if you're like, oh, I'm weird and I sing a lot, like, perfect. People love it. I literally do puppet shows on my stream. Like I have a Carl Sagan puppet. I do puppets, I sing, I do random voices. I think just being you and presenting things in the format that you want to present it in, and sharing your passion. I think some of the most exciting things in life is hearing someone talk about something that they're passionate about. I think that's always a win, and I hear people across every category on Twitch saying that. So I think that passion will show, and it'll make your stream entertaining and awesome. And you learn over time. It's never going to be perfect, but it's worth trying out and see how you vibe with it, because I think it's a lot of fun. And it'd be awesome to have more educational streamers.
I can definitely confirm being yourself and being silly just works. I mean, I started off doing this as a VTuber, and that didn't seem like a natural fit, doing educational content in such a silly way. But if people like it, people like it. They resonate with it. They resonate with it. There's an audience for any different type of topic you want to teach about, and there's an audience for just about any type of method of presentation you want to give. So people who do a lot of singing and puppet shows, people who are very sedate and just deliver information, sometimes that's what people want. There's someone out there who wants to learn from you. And if you have something that's valuable to share, I think you should share it. Because there's, like I mentioned earlier, there's so much slop content out there. There's so much brain rot. People are yearning for something that's real. And I think if you have something that's real to talk about, you should by all means go ahead and do it.
I absolutely agree. Yes. I would definitely love to see more streamers join the Knowledge Fellowship. And even if you don't stream, the Knowledge Fellowship is open and welcoming to you to come learn about different things. And there's a list of a bunch of streamers. I know you were showing some of that earlier, but yeah, it's a fantastic educational community with just anything you could ever want, but you should join as well if you want to stream. Absolutely.
Well, I will let you go, and then we will wrap up and have a few final thoughts before we head out into another TKF streamer on our raid. So thank you very much again for joining us. I'm so glad you were able to be our inaugural streamer and help us kick this off in a really big way. So thank you very much.
Yeah, thank you so much for all the time and effort and everything you put into this. This was awesome. I appreciate you reaching out. Thank you.
Thank you. Thank you.
And thank you everyone for watching. See you.
All right. I want to thank all of you watchers, all of you who showed up to make this a success and to learn from our new friend, Moohoodles, or old friend if you knew them already. I want to just take it back to go ahead and follow the stream team. There's always someone streaming something that is going to be interesting. Twitch.tv/team/The Knowledge Fellowship. We have dozens and dozens of streamers in just about every category: math and science, history. I'm not going to do the Big Bang Theory theme song, but you get the idea. Philosophy, economics, astrophysics, geology. You can find us on Twitter if you're still there. On Blue Sky, we have Instagram, even Facebook. All of these seminars will be on the YouTube channel as well. We have a YouTube channel that is also the Knowledge Fellowship. I will have these uploaded to the YouTube channel after this. And absolutely, you can go ahead and answer any questions or ask any questions you have to Moohoodles. We'll have another link to them right here. And you can also join the Discord, like we said. Astrophysics Streamer. Yes, in fact. Why don't I just bring up the list and show you all of these excellent streamers. Yeah, so astrophysics and aerospace. Das Valdez, EJ and SA. Every type of streamer you can think of. EJ_SA, I know does a lot of stuff. Everybody speaks very highly of them. Yes, and an excellent comprehensive list is in the Discord. In fact, we have a full list. There is a full list of streamers that I can bring up, and we will post in the chat as well. So, aerospace, I2 rocket guy. The I2 is like a rocket, or an R for right there. Yeah, and you can check the list of streamers channel in the Discord. Rocketology as well. Rocket science and aeronautics. But yes, and you can also, of course, follow this channel right here, because we will be using this channel, hopefully, a whole lot more for our monthly seminars. And I hope to have additional monthly streams set up for group discussions, group conversations that we can have together with all different types of people from around the Knowledge Fellowship, within groups, math people getting together and talk with each other, practical technology and programming people getting together and talking about things. So if you have ideas, if you have thoughts about what we can do, I would love to hear it. I would love to hear all of your feedback about what we can do to better highlight, better spotlight our educational streamers and people that you know that stream educational content. In fact, my big hope with this project, with the seminar series, is that we will be able to use this to highlight the new, up-and-coming, smaller educational and informative streamers who maybe just haven't gotten as much attention. They're out there doing great content, but not sure how to get themselves out there. I would love to spotlight them. I would love to spotlight you if you are an educational streamer, if you are making informative content, and you would like to be on this program, if you would like to be interviewed and be able to give a little presentation and talk about what you love, talk about what you're interested in, I would love to have you on so that we can feature you as well. Poison Mouse say we need a 22/7 Pi Day. 22/7 Pi Day. I will have to get E2 to think about that. And yes, follow that Google form right there, linked in the chat. If you know of or are an education streamer, nominate yourself. Nominate someone that you know that is out there doing great informative content. We would love to have them as a member of the group. Even if you don't stream, please join the Discord. We want to hear your thoughts. We're here to learn. And you can also listen to what E2 and BitShepherd are saying in the chat if you would like. That's okay. I should make it clear though, I am a VTuber. So this is all new. This is all new, what people are seeing here. Yes, I talk about health and wellness, and there are some other great health and wellness streamers as well. Tomination Time does excellent fitness stuff. They are an expert in physical science, health and physical science. One other thing I would love to do with some of our TKF fellow streamers is a game stream, a game night. Get some teachers together and have us play Among Us and see how well we can backstab each other. Something like that. I think that would be very fun, yes. Maybe we could even pit two types of the streamers together against each other. We could have the math folks up against the life sciences folks in a game of Wolf or Among Us or Lethal Company or something. I don't know. We could see who's really the best among us, so to speak. Social science versus the physical sciences. Yes, we could do stuff like that. But I would love to hear all of your thoughts about that. So if you have feedback, please reach out to us via our email. Our contact information is in the About section. You can join the Discord and reach out to any member of the committee. E2, as you see there in the chat, is one of our moderators for this channel. Most importantly, though, I hope that you learned something today. I hope that you were able to meet a great streamer that you maybe didn't know of before and are going to be learning some great stuff from in the future. That you might find some new streamers in that TKF stream team list. Because there are a million YouTube channels, there are a million Twitch channels, there's a billion pre-recorded videos that you can watch on any different topic. You could be playing any different game you could imagine right now, but you chose to be here and to listen to something informative and educational and fun. So if you have an interest in that, we have someone out there who is teaching something that you might be interested to hear about in an engaging and interactive format. So it's not just someone talking at you. You can talk directly to them, get to know them, be a part of their community. That's what it is about here, community, and learning in a way that is more than just you hearing someone talk or reading a book. It's a relationship with someone who can teach you and learn from you as much as you are learning from them. So does anyone have any final questions? Anyone have any final thoughts before we head out? Any immediate reactions? Otherwise, you can, of course, reach out in all of those other ways and let us know. You can message us on Twitter, if you still use Twitter, or any of those other socials. Otherwise, our good friend E2 will find us a wonderful TKF streamer who is live right now that we will take our little raid into. Yeah, Rilla Rollo, if you are still using Twitter, what a sad thing. And I very much appreciate it, Avocado. I'm glad that you liked it. X/Twitter/ whatever they want to call it these days. The everything app, the everything crap. If you're on Blue Sky, we have a Blue Sky. We have an Instagram. If you are a Facebook user, there are still people who use Facebook, I guess. So you can check out that. Deprecated, yes. You have none of those, Wes? Well, I know that you have stayed away from social media for the most part, and that is laudable. Very good for your physical and mental health and well-being, for sure. MySpace, anyone? I am from the MySpace generation. I wish it would come back. Of course, I used to have a live journal too, so that dates me, I guess, a little bit. Alta Vista, AOL 8.0. Yeah, so we're going to head on our little raid to Globus the Elder, another fantastic knowledge fellowship educational streamer. So I hope that you will go and show them some love. And I thank you so much for joining me. I thank you for giving me the time and the trust to spend your time with me here for 2 hours today on a Friday afternoon. And I also loved AOL. It's why I use Windows 98 as my own stream aesthetic. And to all those wonderful comments, I'm really happy that I was able to do some work to help out the group. I have been very much reinvigorated and had my interest in doing educational content on Twitch reinforced by being a part of this group. There have been moments where it has been disheartening trying to do educational content on Twitch, trying to find people who are interested in it, wading through all of the people who are out there saying that they do educational content, but they're not really doing educational content, or especially in my field of health, there's a lot of misinformation, a lot of grifters. It's been so great to have an organization that has substantial, legitimate, experiential, and academic-based learners who know what they're talking about and who just want to teach. So I'm so glad I've been able to do something to give back and to help out, and hopefully in the future spotlight you if you are an up-and-coming new educational streamer. So let's do it. Let's head on in to our raid. Thanks so much.